Gitu. Oke, Assalamualaikum warahmatullahi wabarakatuh. Selamat sore teman-teman semuanya. Member ya, sebenarnya anggota komunitas dari Initial Finance Data Analytics Community. Akhirnya setelah libur berapa lama nih? Sebulan atau lebih ya, sharing sessionnya MoF-DAC. Kita adakan lagi nih hari ini, karena sebelumnya kan sudah ada kelas data di hackathon ya, jadi kita anggap oke lah itu Pak. Kayaknya kita fokus ke kelas data dulu, dan sekarang kita mulai lagi sharing sessionnya MoF-DAC, dan kali ini let me introduce, actually it's my friend from Monash University. So he's currently work at Servian, one of the company, like consulting company regarding data analytics and data engineer. So, Assalamualaikum, Bro Mohsin. How are you?
Hello, everyone. So I'll just begin by sharing my screen.
Okay. He will explaining about the modern data pipeline. So what's going on out there? What is the usual approach like data pipeline architecture used by the private and the international company? So maybe Bro Mohsin, the time is yours.
Thank you, Ade. So let's begin. So can you guys see my screen?
Yep, I can see it.
Perfect. So hey guys, I'm Mohsin. I'm a data engineer and consultant at Servian, and I'm a Google certified professional data engineer. I finished my data science mastery from Monash University, same as with Ade. I was his classmate. I also have a bachelor's in computer science and engineering from India. A bit about Servian. We are a consultancy where we focus on cloud-based technology quite a lot. We also do digital, which is web development and so on. And we are into data and analytics, which is data science, machine learning, data warehousing, and so on and so on. And we're also into DevOps and cybersecurity spaces. So let's begin the day. So what do we have today is we'll talk about a modern data pipeline. It's always good to start from the perspective of data and how a data pipeline needs to be developed to serve a specific requirement of data that we come across, or to serve a specific problem. And there can be different kinds of scenarios where we would be requiring a pipeline. It could be a data warehousing pipeline. It could be a machine learning pipeline where we focus mostly upon like ML ops and so on. And we'll then be moving into what's more focused towards data governance part of view. But I'll be covering mostly from like a data engineer's point. So what matters to us and how we deal with those kind of scenarios. Then I'll talk about a bit about like what is ELT and ETL, and which one of them is more modern, and what are the scenarios where one favors the other. And we'll then move into like traditional versus modern data pipelines, which is mostly like on-premise versus cloud. And then we'll have a look at some of the major cloud-based data pipelines, mostly on AWS, Azure, and GCP. And to conclude, I'll be providing what Servian builds on GCP, just a small example for that we developed internally. So let's begin today. So when we talk about data, we usually think about three things, which is the raw data at its most luxurious format, where it's completely random and we have no value from it. Then we have a bit of an information layer where we try to derive something or come up with a business problem or try to solve a particular scenario and so on. And then we move into insights. Insights are particularly interesting because it's a level above information, and it allows us to like make decisions based on the information that we have. So continuing forward, like let's move into what a data pipeline looks like. So data pipeline is nothing but just moving data from one place to another by means of various different steps in between. So these steps take in various types of data or data at its different stages, and it's usually used to perform a, a bunch of operations. It could be like data cleaning, it can be adhering to a data governance pipeline, or it can be data enrichment, where you join multiple data sets together, or it can also be data processing, where you process a particular data in order to get a set of information or a set of business results being delivered to you, and so on. So moving forward, I'll talk a bit about what a simple data pipeline looks like. So we usually have like 4 stages in a data pipeline, which is first is the data source itself. So at the data source, we can think of it as a layer of or heaps and heaps of source databases which are not linked to each other. And then we have a staging layer, which where we bring in data from all of these layers into one particular place, and the way we bring it can be varying depending on the tools we use and the way we bring in, whether it's batch or whether it's streamed and so on. And from there, we then take it into a warehouse where we then derive or perform a set of operations where we try to generate information from this data. And once we have this data, we then move it to the presentation layer where we try to use some reporting tools and so on for like, let's say, for displaying or for showcasing what our data is capable of. And the whole thing is like the entire data pipeline has a governance and it needs to adhere to this. So this data governance is, let's take a look at what data governance is, for example. So it's the art of planning, oversight, and control over management's use of data efficiently and effectively. So why do we need to efficiently manage and effectively manage our data? It's because the first thing is it makes us easy to understand it. It makes the data quality quite easy or quite good, or adhering to, like, let's say, a lot of audit frameworks that are out there, or for government compliances and so on. The third is data transparency. Once we are in an organization and an organization has lots of sub data or lots of business units that generate data themselves, these data needs to be transparent in a way like each organization needs to share its data, but since they have a lot of differences in the systems they might be using, some might be on Excel, some might be in a database, some might be in an app somewhere, some might be a NoSQL database, and all of these needs to be brought together. And there should be a transparency layer between each one of these divisions to share their data effectively in order to make decisions based on what each business can give you. And then we need to like make it easier to access data. So by access data, it means like we need to have permissions for a set of users. For example, data analysts or data scientists or data engineers can have access to one layer of data. Then we have, like, let's say, business analysts, they can have access to another set of layers of data. But it's all evolving based on the business requirement and what the business is wanting to do with itself. And so let's take a look at some of the data governance management bodies. So DMOC is DMBOK is something which is widely used. The other examples could be IBM's data governance catalog and so on. But from a data engineer's point of view, right? So what we are interested is on the metadata management. We are interested in data warehousing and BI management, data security management, how secure our data is, and from the data architect and management point of view, and also from data quality as well. So when we talk about metadata management, when we bring data from different sources, of course, they don't have the same kind of schema, and they don't adhere to the same logics, or they might be having different functionalities. Some might be structured, some might be unstructured, and so on. So we need to build a particular governance framework that would integrate all of this data together. By that, what I mean is we need to structure the data in a way that, like, let's say using the dimensionality model, for example, which is 3NFs and all of the N normalization forms and so on, or we can use the data vault modeling, for example, where we have data divided into hubs and links and satellites and so on and so on. And all of these have to be integrated in a framework which can help an organization build things and prosper. So from a data warehouse and BI management, again, so the framework that you're using for getting the data from various systems into your warehouse and how you're doing it, and all of those have to be cataloged and agreed upon, and a framework has to be built and so on. From a data security, what type of encryption do you require for your data, and how do you encrypt this data, and so on. And again, data security and metadata management go hand in hand, because when you want to migrate a table, or when you want to bring one table from one database into the warehouse, you need to bring it encryptly so that no one can gain access to your data while it's in motion. And document and control management, this is more about like the documentation involved with when you're building a framework and so on, and how properly it needs to be documented, the business values, and are they properly written, are they understood from a business point of view, are they understood from a developer point of view, and the list goes on and on. And this is something which requires a session of its own. So let's probably move forward. I'll talk about like ETL and ELT and what are the key differences. So one is the place where you transform the data along the way and you bring in into like, let's say, a table. So we have a database and we have a warehouse, and we want to migrate a table from here. So we perform all of the transformations. Like, for example, even though our database is relational, it is storing JSON strings, for example, and the transformation logic would then break down the JSON strings into heaps and heaps of columns. And then these columns are the ones that gets loaded into the warehouse. So what happens is you lose the JSON, but what you gain is you gain a set of table and sorry, a beautiful table which kind of represents what the JSON was doing. But again, it's not what the JSON originally had, or you can only bring in as many columns as you can remember. Not all of them can be brought in, and so on. And then that's where ELT comes into place. Like, if you want to do something like this, you can just dump the entire column that contains the JSON into a table and then do the transformations within your warehouse. And the warehouses of today are quite popular enough, and I'll talk about them later in the presentation. So the ETL, they require a specialized transformation engine. Like I said, for transforming your JSONs, for example, you need an engine. Whereas an ELT, you just need to, like, sorry, I mean, a warehouse has its own native engines, or it can scale to its own capacity and so on. And finally, like, when we talk about a ETL tool, both of them have their own strengths and weaknesses. So I'll just go to the next slide where I'll be talking more about those. So more flexibility. When we talk about more flexibility, we need the elasticity of a warehouse. So a cloud-based or an ELT warehouse is where I mean, it shines out on this aspects, because you can run a query for now and you can shut the warehouse. Whereas in a traditional ETL approach, you would run a query and the warehouse would still be on and it would continue be running and acquiring cost and so on. A greater accessibility to data. By this, what I mean is ETL would have a chunk of data, like the JSON example I gave. It gives a beautiful table, but it's not giving you the entire JSON. So you know what's in the table, but you don't know what's in the JSON. Whereas ELT will allow you to look at what the JSON is, as well as allow you to break that JSON into whatever you want. Scalability. So again, the elasticity that I spoke about, the faster load times. So if you query a SQL database or a MySQL database, it can take like up to 5 minutes if the query size is medium enough, or and so on. But in a warehouse or on a cloud warehouse, you can have clusters of clustered warehouse where it takes in resources whatever is readily available, and you can select these resources, and the query that runs in like 5 minutes on a SQL can take you about like 1 minute, or even less on a warehouse or on a virtual warehouse. And then faster transformation times, again, it's again related to the query processing times, where it's quite easy for a query to be transformed in a warehouse as compared to as a SQL server or in on-premise hosted database, for example. So and it's also like less time required for data maintenance as well. So when you have a virtual warehouse and you have a data governance framehouse that is set in, you can easily look into any issues. Like example, if a data comes in and so let's take an example of a streaming pipeline, and it's writing data every minute to a point in time storage. So you can have a particular stream defined where that data is loaded, and then the next row is loaded, and so on and so on. And then you can have an aggregation based on its timestamps. Whereas in case of an ETL tool, it would have to be like loaded into a like the inserted into in a table rather than just loading into a table. And that's where the differences are. So I'll move forward into what cloud versus an on-premise is into a more traditional fashion. So why, now that we know what an ETL is and what an ELT is and so on, and what a cloud and on-premise is, so I wouldn't say that one does that on-premise doesn't have its own advantages. Of course, like you have you have the flexibility of defining your warehouse on your own. You don't need to worry about what external company is offering you. You can define the size of your database on your own. You can define the number of compute engines on your own, but remember, these all come at a handy cost, because you need to actually purchase the hardware to do so. Whereas on the other hand, you get all of these services which are offered to you for like maybe $1,000 per year and so on. And it's easy like to keep a backup and a recovery option, because on a cloud warehouse, when you store something and like let's say a natural disaster has happened or something has happened bad, and your local data center is no longer in existence, but because it's a cloud-based service, it's always been stored in multiple regions, so you can always retrieve from a different place. Whereas in a traditional warehouse, if your building is destroyed, then your data center would be destroyed as well, and there's a huge loss of data. And when we talk about security on cloud-based solutions versus on-premise based solutions, well, we have an encryption layer which encrypts data in every step as it moves throughout the cloud layer. Whereas on an on-premise one, if someone gains an unauthorized access to your servers, then they have access to all of your data. So let's move on to like take a look at what a traditional architecture would look like and what a modern architecture would look like. So a traditional architecture is divided into tiers. So the bottom tier is called as the data generation tier, where data is getting generated from various applications and operational databases and so on. And then it moves into it then moves into the bottom tier, where you have all of the servers and the most of the hardware that you require, like most of the software that you require, like let's say you need a database or a cluster of databases, and you need to define your data marts, and you need to contain a metadata repository and so on. And then you move a tier above, where you have like let's say the physical hardware itself, the server boxes, those big heavy servers, and all of those wire connections and so on that you need to do on your own. And then you have a top layer where you can write queries and perform analytics, and do any kind of stuff. But here's the thing, right? So a cloud warehouse is basically providing you the middle and the bottom tier together into one single package. So I'll show you what I mean by that. So when we talk about here, it's a really beautiful example that I found on LinkedIn from one of my friends. You can see that how seamlessly data from various different sources is getting integrated. So we have data coming in from a database, a legacy database, or like let's say an SaaS application or a web application, and various even various files even like let's say Excels or other spreadsheets that you might have been using. You can all integrate all of these using a data loader pipeline. So a data loader could be an ETL or an ELT based on your choice of operations again. And what it does, it brings data into the warehouse. So now the warehouse performs its governance. So the data governance can have like, let's say, a raw vault setup and then a service data vault setup. And then in between, you have a trusted data layer, which performs all of your integrations and your aggregations and try to enrich. And I mean, it enriches your data to a point where you can get in data from like let's say a database and a legacy system, merge them together, form a new business report that would be helpful for you in the future, and so on and so on. And we would actually keep data lake as a backup where we have one warehouse where we are performing the transformations and another warehouse where we are storing whatever we are loading from all of the other systems into an untouched, so that these data lakes can then be used whenever we have a fail safe proof and so on. And we can share this data like for various different purposes. It can be for insights or stories like data visualizations, exploratory analysis, or even for AI ML purposes, or even building Tableau and Tableau reports, for example, which are quite popular these days when it comes to what presentation can do with, I mean, what business intelligence can do with the data. So moving forward, I'll talk a bit about the features of a modern data pipeline. So again, like most of the modern data pipelines are cloud hosted. So which means that they are SaaS offerings. By SaaS offerings, I mean they provide the bottom tier and the middle tier of the traditional warehouse into a single software as a service. So you don't need a particular hardware. You don't need anything. All you need is just a browser, and you can go on from there. The ability of these warehouses to be scaled to any scale. For example, you can have a warehouse which is just one cluster versus the same cluster based on the query size, or based on the requirements. You can scale it down to like let's say 20 clusters, 30 clusters, or any size that you require to process your data. Then these systems are fault tolerance, like I already told about it, like in case of a disaster recovery and so on. The data is encrypted, and like most of these offerings that I have on the screen, they do it by default, and you don't have to pay for huge huge costs that are involved with like the hardware procurement, the setup, the training for the people to set up these hardware and maintain this hardware and so on. All you need is just pay as you go by billing. Like you pay for the amount of time that your query runs, and that's it. And then you can have real time and batch data processing. So by what I mean by real time and batch is like, let's say if you have a web application and it needs to send a data to a machine learning model for training purposes, and then that machine learning model then needs to determine the sentiments and so on of like let's say a person who is chatting and so on. So all of this is possible with real-time streaming onto modern data pipelines. I'll give an example of this later when I talk about the case study that we built. But a batch data processing, right? So if you're an organization and you're okay with tolerating a bit of delay in the way the data is delivered to you, you can always schedule overnight batches that run 24 hours. So like, let's say today the data is getting collected and tonight the data is getting ingested into your warehouse, and tomorrow you can build your analytics on that data. And then what's more really interesting about modern pipelines is that they're seamless way of integrating with the tools. So they can integrate with various data sources. They can integrate with various tools that are required for insight analysis. So you have that information, the information generation tool, where you can process your data and you can get the insights in based on your requirements, like really fast. And to give a few examples of some modern data warehouses, I would name Snowflake and Amazon's Redshift and BigQuery and Fireball. These are some of the most common ones these days in the market. So let's move forward and let's see how we are able to generalize a particular data warehouse in, like, let's say AWS, for example. So building a modern data pipeline with AWS is really simple. And they have, as you can see on the screen, heaps and heaps of different products that you can use when you're trying to build an ETL. For example, you have your file system, your web services, applications, and legacies and databases, operational databases, and all of those coming in. You can integrate them with serverless Lambda functions, or you can use kinetic streamers or Firehorse that would stream your data from your web application or from your operational warehouse directly into a staging layer where we have an S3 bucket that stores, like, let's say, CSV files or text files or all of those files. So imagine a table coming in as a CSV file, and that CSV file is then CI/CD'd into a pipeline based on the requirement. If you're more into a data warehouse, you will be using a Glue ETL. If you're into machine learning, you can use, say, AWS SageMaker to prepare your data. If you want to, like, have multiple clusters of the way you can perform an ETL, you can have an EMR cluster there where then you have a Glue where it kind of like brings in data parallelly with each other, and so on. And then you have your data warehouse layer where you have a lot of offerings from Amazon. For example, you have Redshift, and RDS supports MySQL and Microsoft Server, Aurora database, and so on. And then you have a NoSQL database, Dynamo, which is really powerful for your MongoDB like operations. And then you have Elasticsearch, which then allows you to expand the usage of these databases. And like in this particular example, we're using SageMaker. So imagine, like, we have data coming in from multiple databases, and then we are trying to build a complex machine learning model. For example, you're the owner of an e-commerce website, and you want to know the people's behavior or people's actions on your website in order to recommend products, but you want this to be in real time. So how are you going to achieve this? You can capture the URL the user is on. You can build a heat map of where the user types. All of this data then moves throughout this pipeline and straight into the warehouse where, like, let's say we have a base model already there, and that base model will take in this new data and give out a prediction. So let's now move out to Azure's offerings of what Azure is capable of, and then we'll have a quick, GCPs, and then let's look at Azure. So GCP, again, it's capable of similar kind of things that AWS does, but GCP has a better solution because we are very familiar with Google Colab, right? And we've been using that for building all of our TensorFlow models and so on. Now imagine that, what if that Google Colab is able to function as a place where you can integrate various chunks of data coming in, and all of this is real time, and you can write your code in Google Colab and see that in real time happening on a website, for example, or happening on a report, changes in a report, for example, and so on and so on. Now let's look at the Azure's offerings as well. So again, it's the similar case. They have a Azure ML Designer Studio. I would rather go with a Databricks in this case, which is another Azure product for machine learning, and I think that's way better than Azure ML, Azure's base ML, simply because Databricks allows you to have copies of your model. Like you can save copies of your machine learning models, and all of these copies would be for a particular point in time, and then you can use ensembling techniques to find out the best model and show the results for the users. And again, all of this is possible with real time. So imagine that a model was trained 2 weeks ago, and another model was trained 3 weeks ago, and another model was trained last week, and a fourth model is trained today. So the ensembling techniques can be used to determine the mean model, mean prediction of all of the models, and choose the best model for that particular user for that particular point in time with Databricks offerings with Azure. And you can have like amazing results with that. So finally, I'll go with what we at Servian built internally. So it was a Twitter tweets sentiment analysis, but at the same time, we wanted these tweets to appear onto our portal as well. So we have tweets coming in from like, let's say, my account on Twitter, and then I have an app engine which takes in these tweets, or which runs the extraction of these tweets and so on. And I use PubSub, which is like Apache Kafka's version of Google. And and we are all aware of what Apache Kafka is, right? Because it's mostly used for streaming data from one place to another with point in time accuracies. I wouldn't say exactly point in time. They do have some nanosecond differences, but hey, when we are looking at a naked eye point of view, it's still point in time, right? And then we're using something like Dialogflow, for example. Like Dialogflow is a chatbot kind of a situation where it allows us to not just a chatbot, but it can be used for like data preparation and data recipes that we need to when we need to model these model the data in a way that we can determine the sentiments. And then once we have that, we then store it into a table in BigQuery. And once we store it to a BigQuery table, it can be easily read by the ML offerings from Google. For example, the automated ML pipelines, or the Vertex AI that has newly been released, or we have things like AI platform from Google, and all of that can easily take up, and all of them have a lot of inbuilt models that can actually do really good examples of sentiment analysis. Or if you don't want to use any of these, you can still bring in Google Colab and write your own model there, and you can determine the sentiments. But at the same time, we are also displaying this text via a NoSQL database, like let's say Firestore. And this Firestore database is then using whatever the tweet is coming in and the reply that's going and so on with a post notification, and it's displaying into our internal portal. And we can see that what's happening on Twitter is also happening at our end as well. And this, I would like to conclude what I had for today. So if you guys have any questions, then please go ahead.
Okay, thank you, Mohsin, for your presentation. So, if I try to summarize the presentation, maybe nowadays, like every data pipelines for machine learning is cloud-based, like service though. So the data, it's managed by the service of the cloud service like Azure, AWS, or Google. So maybe okay. I think that's someone try to raise their hand. So okay. So just try to unmute and then tell the what is that or your equation. Oh, it's Anita though.
Okay, thank you. Assalamualaikum. Hi, Mohsin.
Walaikum assalam, Anita. How are you?
How are you? I'm good. Alhamdulillah. I'm sorry. I think I'm a bit late joining this afternoon's event. May I know among the alternatives that you have mentioned, which one is you think the best for you within your career, maybe this last 3 years, and why you chose that?
Okay, so
Thank you.
since I'm certified with Google, I can say that Google is my favorite, but it's also because I'm really comfortable with Google Colab, for example. But that's not the only reason. When you look at the AI and ML offerings that Google has, they are far superior to AWS or even Azure, for example, because like you have automated ML, and by automated ML, I mean like you can have Kubernetes and Docker in there as well. So if you're working in a larger organization, or if you're working for, like, let's say you want to build an app, for example, and that app is all machine learning based, and you can have your model into these Kubernetes clusters, and these Kubernetes clusters would each run each be running on, like, let's say a user's mobile phone. So Google's offering allows you to um, combine the mean of all the different users who are using your application to provide like, let's say, a mean frequency or a mean prediction to one particular user. But that doesn't mean that the model is outperforming itself, or it's having a high bias or a high variance trade-off and so on. That's not happening in this case, because Google is also applying regularization techniques, and also like with having something like Google Colab or Jupyter Notebooks integration with AWS or GCP or Azure, you can always tune your models based on your performance. But having the ability with Kubernetes, where there are nodes and nodes of where each customer is treated as a node, and a model is spin up when someone picks up their phone, I think that's really amazing for me.
Okay, thank you. I'll ask again, but maybe other wants to ask the
Okay.
question.
Is there any other one who wanted to ask another question, or okay? Just let me ask you your like the question that bothering me about this one, the data pipeline. So you said that nowadays, like every approach for data pipeline is like cloud-based now. So how about if me and my office, like as a government, who like to use these modern data pipelines, but we one of the concerns that we have is our data security, because it's like governmental data, and if we use third parties like Google, Azure, or AWS, maybe there's a a trust issue like data security, and how can they save or secure our data there, because it's like government data. So is there any other options, or is there like approach from the provider for the governmental data?
Yes, so for this particular purpose, all three of the service providers, and I would like to add even IBM and HP onto the stack as well, all of them provide like servers which are reserved for the government organizations. So in case if you're looking for high security data warehouses and high security data pipelines, you can always go to one of those regions, or you can have account in one of those regions, and you can build your pipelines. But again, the thing with cloud is like you can manage the type of data that you want to store as well. So you still have your operational warehouses, right? So in those operational warehouses, you can store sensitive information, and then you can decrypt that sensitive information with, like, let's say PII standards, or PII versus NPII, which is your which determines which data is considered to be, like, let's say want to be treated as secret, versus which you don't want to be treated as secret. And again, these are all things that you can always tune to your advantage when you're dealing with a data governance body, for example, over here. So by having a data governance that talks about the security aspects and that talks about how or who would have access to the data and who can see a PII data and who can see a non-PII data and who can see both of this data. It is something that an organization can take care of if they are building it on cloud platforms. I hope that helps.
Yeah, because do this provider have like option for like a contract or like agreement if our government want to have a what is it relation like using their service
Yes.
in your
So
knowledge?
yes. So what you could do is like before you start a project, you can always approach Google or Microsoft or Amazon and tell them about your concerns. And what they would do is they would rather design a pipeline just for you, and it would adhere to all of your security issues, and they would then suggest you where you need to or with whom do you need to even integrate such projects with or build such projects with. So they provide you the solution, and they also provide you their partners. For example, at Servian, we are a partner of Google. So some of the projects that we get are directly from Google, and that's because we are known for our quality in Australia and what we deliver. So it kind of depends upon. So in this case, if you reach to them, it kind of depends upon your reputation and what kind of data you have, as well as as well as if you're going to a third party to build it for yourself, what's the reputation of the third party who's going to build it? Are they trustworthy or not? And believe me, like being a partner for any of these organizations means like we have accomplished a lot of projects for them.
Okay, thanks for the answer. So I see the other one, like one person raised their hand. So yeah, to see your question. Oh, Mas Oki. Silakan, Mas.
Assalamualaikum.
Hey,
Hi, Mohsin. How are you?
I'm good. How about you?
Good. Good. Thank you. I just wanted to ask. Let's say that in the next few years, we are adopting the ELT in our government. So, from your explanation that you said that the ELT is lower in maintenance cost, right?
Yeah.
But I think I want to know about your opinion about that. Because that is exactly our challenge in adapting the ELD. Because to reduce the maintenance cost, I think we had to have like some kind of the excellent infrastructure or the human capital or something. Uh, what is your opinion about that? I mean, how can we embrace that technology that changed in ELT?
So the question I would like to rephrase it. So it's not
Hmm?
just ELT and cloud, but cloud can also work with ETL. So that's a misconception. So I would correct that. Regarding
Oh,
your thing about storage, right, or maintenance, right? So the maintenance cost is reduced because of the fact that you no longer have to maintain those hardwares, those big chunky hardwares that require a lot of electricity, a lot of maintenance people to maintain all of those wirings and even setting up those servers or making sure that the storage capacity on those servers are replenished every now and then and so on. So by going to a cloud approach, you always have a third party provider who is doing this on their own cost, and you don't have to worry about this. All you need to take care of is of your security of the data that and nothing else. And you can easily do that by giving the right permissions to the users who have access to it. So that's the reason why you have low maintenance costs, because your manpower for maintaining a system is reduced.
that's good. Thank you.
Okay, nice. So we have another question in chat box. Okay, I'll just like read it, or should I ask Aiza to say the question by his own?
Yeah,
Aiza, are you here?
Okay, I think I will ask some question. Hi, Mohsin.
yeah,
Based on your experience, what is the main success factor to apply the data integration platform for the multiple databases? Because we have several database platform, like each of them are different platform, and how to, what is the main success factor to apply that integration?
so the main success factor would be to decide upon a metadata dictionary and also like a dictionary of, like, let's say, of your reference codes or so on. So like, for example, you have financial service record database, and then you have a database consisting of home loans, for example. How would you want to integrate these two? Because they are two different services, right? And two different business units are taking care of it. So the financial service follows a schema which is 3NF, and the home loans can follow a schema which is not 3NF. So now you can decide on a data governance strategy, which where you decide on whether you want to continue with the dimensionality model of 3NF, or you want to bring in another model, for example, data vault, for just for the sake of it. And you want to model the tables that are in your financial system based on data vault modeling. And also you want to model your tables from your home loan system into the data vault modeling. And that way you have both of them into a single architecture. I hope.
Thank you. Okay, thank you.
Okay, nice. Maybe someone else will want to ask. Okay, Mbak Rosa, raise your hand. So just say your.
Yeah. Excuse me. I just want to make sure. Are you saying data vault modeling?
Yeah, data vault modeling.
Yeah. Currently in my organization, we're trying to implement the data vault, but in Indonesia, we hardly find any successful organization that implement it. So can you elaborate more about your experience in using the data vault for data integration?
Yes. So in my experience, I've been working for a client in Australia, and the client is successful, quite successful in integrating with data vault modeling. They have things coming in from various different business domains and different file systems, and different live systems coming in as well, which are point in time accurate and so on. And also we have something coming in from a telephone records, like a person is calling, and whatever they speak in that call are also being brought up into our warehouse and so on. So the data vault kind of like loads the data from all of these systems and brings it adhering to the satellites and hubs and links format, where we have a data dictionary defined. And this data dictionary is for all of these systems, and it's not just unique to one particular system. So by that, what I mean is your telephonic records might have, like, let's say, a customer number, and that is the same customer number that you have in your sales transaction database, right? So you would model something in a way where you have a hub which has your customer records stored. By customer records, I mean the customer primary key and what value it stores. And then you have your link where you have a binary key value representing what you have in your hub. And then you have your satellite that defines the things about your customers from, like, let's say, your phone records and from your sales records. And now you can easily merge these two tables with the link, with the help of the binary links, or by the customer numbers that are present in your hubs, correct?
Yeah. One thing that my big consideration when implementing the data vault, I think that we have to do many splits regarding the input table, right, from the data source. So currently we've already had the data warehouse where we just put the data as it is, as the row, and then just do simple modeling, like more to the like star schema, but not the ideal of it. How do you think we put the data vault in there? Because it's like we put more pressure, right, to the operational system when we have to stop and split the table into hub, satellite, and link, and then we need to join them back, and then after that we still have to do make a star scheme or snowflake snowflake, and then that's I still have some issue regarding that.
Okay, so I would like to ask you, so when you said about like you have an operational database and you write things straight to that operational database, and then you try to apply the star schema or any other schema logics into that same database, is it?
Yeah.
Yes, so that is where you're going wrong. So what you need to do is your operational database is going to stay the way it is for your business purpose, but for an overall organization point of view, you need to have a warehouse which is separate from it, where you have the data vault modeling implemented, and you can extract this data, like I said, about the batch processing or the real-time streaming, right? So you can implement a 24-hour batch cycle if you're okay, or you can have a real-time streaming which extracts data from your operational database, transform it according to the schema logics of data vault, maybe star schema or snowflake schema, and loads it into a data warehouse, for example. Again, snowflake take for the case of it.
Okay.
And and your next point was about joining all of these and building a business report or coming up with insights and so on. So you can do that within Snowflake, for example. And Snowflake has various connectors. Like, for example, you can connect to Power BI, and that Power BI would then export your table, the joint table that you have based on your business logic, right? It can go to it can be taken into Power BI, and you can build dashboards from there, and so on. You can do that. Like the thing about data governance for a warehouse is you need to define what a tool is for rather than doing everything into one.
Okay. How about the bad data?
How about
bad data? I mean, more like missing value and the data source that doesn't fit the fixed scheme of the table. Have you any experience in handling the bad data issue, bad data quality issue in when you are orchestrate a data architecture from end-to-end data pipeline?
Yeah, so let me take the case of, like, let's say we have a operational table that it's storing records from, like, let's say a website, and that records are getting extracted into an ETL and brought into a data warehouse. Then that data warehouse, right, it can have history of records. So now your operational data warehouse will have one set of records, whereas a particular point, or like let's say the history exists in the warehouse and your operational stores data only for that particular day. So you need to implement a CI/CD logic over here, which would take in only those records that have changed over a period of time and insert only those records into your warehouse.
Okay.
I hope that answers your question. In case if you're dealing with non-structured data source, then again, like you can have various transformations along the way or within the data warehouse itself, where you can again delete those records which you feel are not relevant to your case.
Okay. Thank you, Mohsin.
Yeah. Thank you, Barosa. So, any other question from participant? What is it? Oh, Mas Yayan atau Pak Yayan? Maybe you can, tell your question directly. just unmute your speaker or microphone. Ryan,
Thank
sorry.
you.
Yeah.
Hi, Mohsin, how are you?
Hello, I'm good.
Yeah, I just have this question. I think it has something to do with what Ade has asked before. It's about security. My question is more about the regulatory concerns, because treating confidential governmental data is limited by the regulatory concern. And perhaps that is why not so many government choose cloud services. For example, in Indonesia, we have this regulation that, like limiting the storage and also the processing of the data within the country. So is there any cloud option that is specific for government clients? So not only for the storage, but also the whole entire data pipeline should be inside some sovereign territory. So do you think is there any customization available?
So that is something I cannot answer you because I'm neither from Amazon or Google or Microsoft. But what I can say is like they do have regions or government specific regions. But at the moment, these regions are in the United States, where the UN rules apply rather than the rules of the US. But like you said, right, if you want something sovereign to Indonesia, for example, or Australia, for example, or India, for example, then I think there are some data centers within Australia and India, but I'm not sure about if there are any Amazon or GCP or Azure data centers within Indonesia. So that is something which I'm not in a position to say more about, like just for the storage.
Got you. Thank you. So it's pretty limited, especially from the perspective of government. Like most of us are here in the government, we feel really curious to try out this sort of cloud services, but like we have this regulation to obey. So
yeah,
kind of like in the middle. So do you have any suggestions on how we can probably like try out and some side projects which are not related to governmental data, that we can have the picture of how it works?
yes, sure. So like the case study that I showed you about Twitter sentiment analysis, and at the same time streaming the tweets, you can have a mock project. Like let's say take Airbnb's for example, and you're trying to figure out in your specific country or in your specific city, which are the so you want to classify the listings over there, or you want to know more about the ratings or ratings that are coming in, or you want to make note of, like let's say if any new listing is added, and what is that listing going to be valued at, or like let's say you are sitting in so I wouldn't say sitting, so let's take the example that from your house to your office, like which train or which train do you need to use, or which bus do you need to use. So you can make all of those analysis without actually using the mainframe cloud services, like without actually using a cloud storage service. You can just have all of this data somewhere available in an operational warehouse that is physically located, maybe on a server within your sovereignty. And this particular tool would be like taking in data, like let's say chunks of data, maybe 10,000 records at a point in time, and those 10,000 records are then moved into an analytic pipeline, and that analytic pipeline would then give you the outcome that you need. And once that outcome is done, you can then transport it back to a Tableau layer or a Power BI layer, or like let's say there are quite a few ML operational side tools as well, like Data Loop and Data IKU and so on, where you can store data again back on on-premise. So the ETL is used only for or the ELT can be used only for like getting the data, transforming it, and then not keeping a copy of it and storing it back onto on an on-premise system. So that could be done as well. Even though you're using a cloud service, but you're not storing anything.
Okay, thank you. One more last follow-up question. Do you know any government entities that use commercial cloud services, or should we probably opt to consider private cloud, creating our own private clouds?
So in Australia, we work on quite a few of New South Wales and Victorian government projects. And we even have a few projects from the federal government, and most of them we implement on GCP or AWS stacks at the moment. So most of them are data integration or machine learning projects that we do for them.
Great. What do you think about private cloud?
Making your own cloud?
Yeah.
Oh, well, if you have the hardware and the budget, then go ahead. Who's stopping you?
Okay, thank you very much.
No worries.
Okay, nice conversation. So, yeah, there's an option to create like a private cloud, but still, we need to analyze the cost and benefit for creating that private cloud though. So, any other question from the participant? I think I remember that Anita still have another question or canceled. Okay.
I have many questions, but I will ask him in private.
Well, you have my number, so you can do that.
Okay. Any other question from the participant? Okay. I think so. If there is no other like question from the participant, I think we can conclude this talks and discussion about the modern data pipeline. So maybe yeah, if I can summarize the discussion today. So we're talking about nowadays like how we move the data from the sources to the one that utilize the data so that we can create a product like ML product or maybe like service or analytical report or something. So there is a data pipelines, but nowadays data pipelines is like on cloud. So every data pipelines used are cloud based now, like Google. Google Cloud Platform and AWS or Azure. Those are example of the provider for the modern data pipeline. So there are benefits, but sometimes we have something to concern with, like governmental data security issue and stuff. So maybe the other option is like making private cloud. And yeah, there's a lot of things to analyze, like how we can create like private cloud or something like that. Okay, maybe even though it's like still have like time, but I think we can conclude this session, today's event. So thank you for Mohsin for your speech and your today. So okay, maybe kita ketemu lagi aja kali ya di closing dulu event kali ini. Nanti mungkin ada event-event terkait dengan sharing session lagi dari MoF-DAC. Gitu aja. Sorry. Okay, the recording will be like uploaded to our YouTube channel, MoF-DAC. So you can watch it, like rewatch it on the YouTube channel, like MoF-DAC YouTube channel. Okay, thank you for all participants that attend this meeting. We will see you again on the next sharing session, class or something. Okay, begitu aja mungkin. Assalamualaikum warahmatullahi wabarakatuh.